Hello. So today I'm going to show you how to find all the zeros of a polynomial. But they've helped us out a little bit because they gave us one of them. So if we have one, we can at least use that as a jumping off point to find the other ones. So just a few things to talk about if we're looking at number one. So first I take a look at its degree. It's degree 5. So that means I'm going to have 5 total zeros at the end of the day, okay? And they gave me one of them. So they've given me -3 over here. So I have one, I just have to find the other 4. And whenever you're doing any of these, the very first thing you want to check is, can I factor this? And this one does happen to have an x that can be factored out of the whole thing. So I'm going to start off by doing that. So let's pull out an x. So 2x to the 4th plus x to the 3rd minus 23x squared minus 4x plus 60. Okay, so now I actually know 2 of my zeros. They gave me -3, and if x is a factor, that means 0 is one of my solutions, right? If you plug 0 back into this original, aren't you going to get out 0? Because remember, that's my ultimate goal. I'm going to be replacing y with 0, and I'm solving for x. So one of my answers, actually, let's see if I can do this. I'm going to keep a running tally of my zeros up top as I find them. So they gave me -3. I just figured out that 0 works as well. Okay, but now I still need to find the rest of them. So now I'm looking at this massive thing here, okay? If it were 4 terms long, I could do things like try and factor by grouping. Yeah, this one's kind of a mess. So I'm gonna go back to the 0 that they gave me. They gave me -3. So I'm gonna do synthetic division into this whole crazy thing. I'm going to plug in -3. It should come out with a remainder of 0. They're telling me, hey, this is one of the zeros. It should work. But then I can at least factor it down into something even smaller. So let's do that. So I'm going to pull down my coefficients. 2, 1, -23, -4, 60. Make sure you're not missing any. 4, 3, 2, 1, none. Got them all. Okay. And now I'm going to plug in -3. And I'm expecting to get a 0 over here. If I don't, I know that I've messed up. So let's try it. Drop down the 2. -3 times 2 is a -6. 1 minus 6 is -5. -3 times -5 is 15. -23 and a +15 is a -8. -3 times -8 is a +24. -4 and +24 is a +20. -3 times 20 is a -60, and I end up with a 0, just like I was expecting. Okay, great. So what did that do for me? I already knew that -3 worked. Right, but now I also have, those are the coefficients of an even smaller factor, right? So I'm breaking this down chunk by chunk by chunk by chunk. So if this is my remainder, right, then the resulting polynomial here, this would be my constant, this would be x to the 1st, x squared, and this would be x to the 3rd. Okay, so let's look at what I'm dealing with here. I'm going to rewrite that. 2x cubed minus 5x squared minus 8x and a +20. So essentially, guys, what I've done so far is I have factored this thing down. They told me that -3 works. That means x plus 3 would have been a factor of my original polynomial. And I also had that x that I pulled out from that was kind of one of my first steps. So right now, if I just take a look at what I've done, I just want to make a big point about this because this is kind of the crux of the whole chapter here. This original polynomial, I have now factored down into these factors. If I were to multiply that all back together, I'd get right back to my original. Okay, so that's, I'm chipping away at it. I don't have a way to factor the original just, like when I'm factoring a trinomial, I have tools there. Here, all I can do is just test for those zeros, right? So anywhoosers, all right. So looking at where we are now, we've got, let me switch colors here. I already know that the 0 that came from you is 0. The one that came from you is a -3. Now I'm left with this thing here. That is a 4-term polynomial. I'm going to go ahead and try and factor by grouping and see if I can. If I can, great. If I can't, I'm going to have to keep going with synthetic until I can get down to a quadratic that I can solve. But let's see what happens if I factor by grouping. So remember to do that. You're literally going to split the polynomial down the middle. And if I look at the left-hand side, let's see, 2x to the third minus 5x squared. Well, I could take an x squared out of that, and I'd be left with 2x minus 5. And then on the right-hand side, I could take out a -4, and I'd be left with, well, what do you know, 2x minus 5. So this one, I can do factoring by grouping. And I know that I can because when I just did that, those two parentheses match. So now that means that this, hold on, let me get my colors. This polynomial right here just factored into this. I take the 2x minus 5 that they share, and then the other one is what's out in front. So the x squared minus 4, those two come together. Cool. So that crazy thing in the red box just factored into 2x minus 5 times x squared minus 4. So if I bring down the other two factors over here from before, x times x plus 3, now I have this thing factored down even more. And I'm actually kind of almost done because I know all my answers are going to be. That one's 0, that one's -3. This one, if you set that equal to 0, right, 2x minus 5 equals 0, add the 5, divide by 2, you would get a positive 5/2. And then this one, what happens when you take x squared minus 4 and set it equal to 0? Add the 4 to the other side, and then take the square root. What's the square root of 4? Hopefully you're saying not just 2, but positive and -2, right? So how many solutions was I supposed to have? Remember way back here, we said 5. How many do I have? I have 0, I have -3. I'm going to keep the list going up at the top here. I just found 5/2, and I just found positive and -2. There are my 5 zeros for this polynomial. Okay, so then I ask you to graph this. So, gosh, how can I do this and not erase everything that I have? Oh, I know. I gotta slide over to the next screen. I want to keep what's up at the top there. So let's see. I'll just have to erase like this. While I'm doing this, hope everybody's doing all right out there. If you need anything, you just reach out. We've been all right here. I'm lucky that my son he's only 3, so he doesn't totally, he doesn't get that he's stuck at home with mom and dad yet. Okay, all right, let's slide over now. Yes, okay, so now I'm asking you to graph number 1. So you already, well, let's just real quick. If I'm looking at number 1, remember that it's to the 5th degree. So think about what the end behavior looks like for something like that. Okay, and let's see if we can get this all on here at once. So I'm going to go ahead and put the dots at all of my x-intercepts. So this thing will cross the x-axis at -3, at 0, at 5/2, which is 2.5, right? 2.5, so I'll do my best. 2.5, and then at positive and -2. So at positive and at -2. Okay, and then think about the end behavior. So it was to the 5th, and the leading coefficient was positive. So hopefully you're remembering, okay, so that means this side's going to go off like that, and this side's going to go off like that. Okay. All right. So none of these are double roots, so I know it's passing through at each point. Okay, so, and I really have all the critical points that I need. I have my y-intercept, you know, so I'm not that concerned with you plugging in numbers in between because I know that everything's passing right through. So this is just going to bloop like that. This, I don't know how low it's going to go, but again, we're just sketching here. And this is going to bloop and then off to infinity like that. Okay, so yes, I'm just sort of, hold on, let me switch to these. I don't really know how high or low these are going. So if you want to have a more precise graph, feel free to plug in those values and get specifically how high and how low they go. But for my purposes, the things that I'm going to be looking for are, do you have the correct end behavior, and do you have all of the critical points sort of mapped out? So you should always have your y-intercept. We got lucky here that was part of, you know, my answer. So I didn't have to find that separately. And then just checking that you have all of your x-intercepts correct. All right, so let's try the second one, which is a tiny bit trickier, but I think you will do just fine. All right, so this one is another one that, and there wasn't really a way to, well, let me try this. Yeah, maybe I can do like that so I have more writing room. Okay. All right, so again, I need to find 5 zeros because this is another one to the 5th. And they gave me one of them, but actually they kind of gave you 2, okay? So when you have a 0 that has an imaginary number, or it's any irrational number, so if it had a square root in it, remember that they always come in pairs. So it doesn't show up to the party by itself. It will always have its conjugate with it, okay? So that means I actually gave you 2 zeros here without you even knowing it. So I'm just gonna, again, I'm gonna keep a tally of all my zeros. So one of them is gonna be -3 plus I, the one that they gave me. But then it's also going to bring its conjugate to the party. So remember that it's only the sign in the middle that's gonna change. So that -3 stays as it is. So -3 plus I and -3 minus I, both of those are zeros to this. Okay, does that make sense? So, from here, you have some options. So what you can do if you want, you can go ahead and you can find your list of possible rational roots and then start plugging them in. Or you can take, oh gosh, I wonder, would I do that? I think that would probably be fastest. Your other option is to take these 2 factors and put them into their binomials and figure out the quadratic that they came from, and then divide that into this. I honestly think that would take a lot longer though, especially given that my n number is 20 and the leading is 1. So my list isn't going to be that bad. I'm going to do it that way, to be honest with you, because I don't think they're going to be too bad. So my possible rational roots. So remember, that's going to be positive and negative factors of this divided by factors of this. And since my lead coefficient is just 1, it really just turns into the positive and negative factors of 20. So positive -1, positive -2, positive -4, positive -5, 10, and 20. Okay, so those are all the ones that could possibly go in. I'm just going to start off with 1 and see what happens. So let's drop down my coefficients. 1, 8, 21, 12, -22, -20. Okay, let's pop in a 1. What's that, 20. Oh, what do you know? See that? +1 works. So I'm going to put it right up in my list. I have 3 of them already. I only need to find 2 more. Yes. Okay, so let's see. All right, I have 1, and now I'm looking at, this would be x squared, x to the 3rd, x to the 4th. I still don't have enough to just stop. I'm gonna keep doing synthetic. I'm actually gonna erase all that I just wrote. Oops, went one too far. Okay, I'm gonna keep going because this crazy thing here, I still can't factor it. It's still too big. So I'm gonna keep going with my out of this list. I'm gonna keep plugging things in until I find another 0. Okay, and then hopefully I can get it down small enough that I can just factor it from there. But I'm not quite there yet. Okay, so I'm looking at this, and I know, see, one thing that I notice is that all of these are positive. So I'm not going to bother plugging in any positive numbers in this list, because how would they cancel out to be 0 at the end? They wouldn't, right? So I'm only going to plug in the negatives. And remember, I'm kind of done with my remainder here. So let's plug in -1 and see if -1 works. Well, lucky us, it did. So now -1 is another solution. So there's just one more to find. And I'm just looking at what I have and seeing if I could factor by grouping. And I don't think I can. Oh, bummer. However, I still have all my coefficients that are positive. So I'm going to keep plugging in negative numbers. I'm going to plug in -1 again because it could be a double root. You never know, and you don't want to miss it. No, that's not going to work. So -1 does not work. Let's try -2. Yes. All right, so -2 is my last one. Now this are the coefficients of x squared plus 6x plus 10. Guess what? If you were to, this doesn't factor, right? There aren't factors of 10 that add to be 6. So in order to solve that, I would have to do, you can complete the square, or you could do a quadratic formula, but I mean, there's no reason to bother. But if you did, guess what? Those are the answers that would come out of that. Does that make sense? So when you had this, what you could have done is you could have gone from there using these two, and you could have found this as your first factor instead of plugging in these rational roots if you wanted. I just didn't think it was going to save any time, but it actually might have. I think we got lucky that I kept picking ones that worked out really quickly. So I don't know. It's up to you. Let's go ahead and graph this thing now that I have all the important pieces. So now I can't graph imaginary solutions on this. So let me just graph these rational ones. So +1, -1, whoops, and -2. Okay, let's talk end behavior. It's to the 5th again. The leading coefficient is positive, so it's going to go like this and like this. Okay, no one is a double root. Now, here's what is going on here. It probably doesn't look something like this. That's usually going to be an x to the 3rd. So an x to the 5th, it's probably going to have some other funky little thing that happens. So it might do something like this, where down here there's like a just like a bloop. Or, no, wait, hold on. It might even happen like this, where here there's a divot. Okay, but again, since we are just sketching, I'm not overly concerned. What I do need to see is that you have 1, -1, and -2 on there, and your end behavior is correct. All right, so hope this helps. Let me know if you have questions. See you later.